Hello all, my name is Ajay Shastry. I, on behalf of myself and my co-authors, would like to present our work, Path-Based Attention for Highly Occluded Pedestrian Detection with Transformers. Pedestrian detection is the task of localizing and classifying pedestrians in an image. So given an image is an input, our task is to localize on where the pedestrian is and draw a bounding box around it. It has its application in autonomous driving, surveillance, and robotic navigation. Detecting pedestrians in the scenarios of high occlusion is very challenging. The pedestrian can be occluded by another pedestrian or by another object. And when the pedestrians are very highly occluded, most of its body parts are not clearly visible, causing the network to fail. People have tried solving this problem using the existing CNN based methods or convolutional neural networks. The CNN architectures make multiple predictions per pedestrian. So there is a need for a post processing step to remove these duplicate predictions, and NMS is one such post processing step. NMS or non maximal suppression is a heuristic based method which uses the overlap information between two bounding boxes to remove duplicates. And when there is a scenario of high occlusion, it erroneously removes one of them. Let's try to understand it using an example. Assume that there are two pedestrians very close to each other and our network predicts both of them. Since NMS uses the overlap information to remove duplicates and these two bounding boxes are highly overlapping, it removes one of them. People have tried to remove this bottleneck using transformer based object detection method. And Dino is one such object detection method which uses no processing step to remove duplicates. Dino is a transformer based end to end object detection model. Dino considers object detection as a set prediction task and does not predict duplicates. But when we try to extend this method to the task of pedestrian detection, surprisingly, it does not have a performance on par with its CNN counterparts. Our task is to investigate the failure, and our analysis revealed that the feature extraction module was the reason behind this failure. Dino uses something called as a deformable attention to extract features from the images. Deformable attention uses key points on the images to extract the location from which features can be extracted. Our analysis revealed that the misalignment of the key point is the reason behind the failure. Let's try to understand using an image. Assume the green bounding box was a prediction made by the network and the blue color points were the locations of the features from which the features were extracted. We see that these points are spread sparsely across everywhere and some of the key points are present on the background rather than on the foreground. So when features are extracted from these locations, the quality of the feature made is very bad, hence causing the network to fail. We try to improve this by exploiting the structure that the human possesses. We know that human has a structure associated with it, and if we make the attention concentrate on these regions, then we can extract better features. So we made the network concentrate on the region of head, hands, legs, and extracted features from these locations, aggregated it, and then performed the detection, because of which the network started performing better. When we try to observe what is the implication of integration of our module, we see that the network was initially putting the key points this way, but with the help of our module, we see that the key points are in the regions of face, hands, and legs. So improving the quality of the feature. When we try to visualize it in the scenarios of high occlusion, we see that this bounding box, blue color bounding box, is very highly occluded. And when we visualize its attention points, we see that most of its attention points are in the visible region. And when the features are extracted from the visible region, it creates a better feature, helps in better detection. When we perform a qualitative analysis and compare our performance with the existing state of the art, we see that our method performs better. The green color boxes are the predictions made by the network, and the red colors are the missed ones. We see that our method performs better in comparison with the rest in the heavy occlusion scenario. And when we perform a quantitative analysis and try to analyze the performance of our models on two benchmark data sets, CityPersons and CalDEP, we see that our models have the least miss rate in comparison with the rest. And in the cases of heavy occlusion, we see a very high improvement. Thank you.